On my Kubernetes microservices course, there's a link in the description if you're interested in that, I show how to build a full application which we then deploy to a local Kubernetes installation. But in the second half of that course, and I'm showing you some screenshots from the course right now, we move across to deploy it to the cloud. And for the course I chose to use AWS, Amazon Web Services, for two reasons. Firstly, AWS is right now by far the most widely used cloud platform on the planet. It is dominant, really. That might change, of course, but at least for the near future, AWS is the most widely used. But the other reason that I used AWS for the course was simply because AWS is the cloud platform that I use in my real work. I'm by no means an expert in AWS, and there are large parts of it that I've never used. It's actually a huge platform. But I have used it almost day in and day out for the last nearly 10 years. So I'm really comfortable working on AWS. But one thing I promised when I recorded that course was that at some point in the future, I'd also add some extra material to demonstrate that one of the real selling points of Kubernetes is that it makes migrating from one cloud platform to another cloud platform much easier than it would otherwise be. So in this video, I'm going to take the Kubernetes application that we developed on that Kubernetes microservice course. There's a link in the description if you want to see that course. And we're going to port it across to Google Cloud Platform. So this is quite good fun for me. You have to bear in mind, I have almost no experience on Google Cloud. I have played around with it a little in the past, but in no professional sense. And I would never try to pitch my services as a Google expert. Now, I'm sure that many of you watching this video will see me doing things in a clunky, non-efficient way. There are almost certainly better ways of doing what I'm going to be doing on this video. So if you're an expert on the platform, then you can refine my process. But I'm here really to show you how easy it is to port a Kubernetes application from one platform to another. So let's get started. Well, just in case you haven't seen that course, a quick review of what we do on the course. We have a microservice architecture which consists of several Docker instances. The application that we build on that course is a tracking service called Fleetman, and the idea is it's some kind of haulage company, a vehicle company that want to track the position of their vehicles in real time as they move across the planet. And you'll see the application towards the end of this video when we have it running on the Google Cloud Platform. It's basically a map with some positions. And over the course, it takes quite a lot of work, but we built this file, workloads.yaml, which defines a series of Kubernetes deployments. And each deployment contains a link to an image. So the coding of the application has already been done. These images already exist on Docker Hub. Now, all of these YAML files are available on my public GitHub repository, and there's a link to that repository in the description below this video. And then we have a YAML file defining a series of services, and these are basically networking endpoints for some of the Docker images. And we also have a separate file called mongostack.yaml, and we use a Mongo database in this application to store the history of where all of the vehicles have gone. So again, if you want full details of how all of that works, check out the Kubernetes course. There's a link in the description. The final file that is relevant for today is the storage.yaml file, and this defines the hard disk configuration that we're going to be using for the Mongo database. And early in the course, we write this file and we set up a persistent volume, which is just going to be mounted on a local directory structure somewhere. Now that doesn't work once you move into the cloud, so as part of that course I showed you how to upgrade this to use an Amazon SSD drive in the cloud. And so at some point in that course we created a second version of that file called storage-aws.yaml, Here's the important part. This line here is saying we want to use AWS as the EBS as the Elastic Block Store on Amazon, which is basically hard drives. And the GP2 is just Amazon code for we want a general purpose hard drive, which is an SSD drive. I just want you to notice that in this little block here, there is a specific reference to Amazon. So they're the 4 important files that we use to define the application. And on this video, we'll see if we can take those files and deploy them to Google. So bearing in mind that I'm not a Google Cloud Platform expert, I'm not going to go through all of the deep details of Google Cloud Platform. I'm going to assume that you are capable of going to the Google Cloud Platform, create an account for yourself, and create a project. I happen to call the project Fleetman. Now, as far as I understand things at the time of recording, if I click through to the billing link, this is a bit better than Amazon in my opinion. You are given a set of credits which actually has a cash value, and you have 1 year to spend those credits. So as things are for me at the moment, I can use 230 Great British pounds approximately of resources on this platform. Now, even though we do have this amount of credit given for free, you still have to give your credit card details. Now, according to the sign-up page, the credit card is just to prove that you're human, and they are not going to bill that credit card when you run out of these credits or when the 365 days expires. They will ask you again to confirm that you want to opt in to billing. So that's quite a big difference to Amazon. On Amazon, you've constantly got to be careful that you're not inadvertently spending money that you don't know about. So this is quite good. I must say I'm quite impressed by the free tier on Google Cloud Platform. However, just as on the course, I'm going to constantly remind you that when you finish doing the work on this platform, you should delete everything that you've created. If not, at least just to make sure that you don't burn up your free credits when you could be keeping them. So you are going to have to give your credit card details, and you'll probably find that you'll be asked for them when you click through to the first service that we're going to use. We're going to use the Kubernetes engine right here. And I'm going to click on the clusters link. Now, if I remember rightly, it was at this point when I was told, sorry, you can only use the Kubernetes engine if you have enabled billing. And I had to click on enable billing and give my credit card details. However, don't forget, assuming you're new to this platform, you will still be using your free credit. So we're not being charged for this work. On the training course, we had to set up a Kubernetes cluster on AWS by hand by running lots of command line tools. And the tools we were using was called COPS. Now, one of the great things about Google Platform is that is all built into the platform through this managed service called Kubernetes Engine. By the way, there is a managed Kubernetes service on Amazon. I'll just switch to Amazon for a moment. It's called EKS, the Amazon Elastic Container Service for Kubernetes. It's quite a mouthful. I didn't cover that on the course because at the time of recording, Amazon EKS was still kind of in beta or beta. It wasn't available in every single region. By now it is starting to get some use. I will be adding a new chapter to the Kubernetes training course at some point in the future. But we're here for the Google equivalent, and all we have to do is click on Create Cluster. We'll need to give the cluster a name. I'll go for Fleetman-cluster. Description optional. We can decide whether we want the cluster to be spread across multiple zones. So just as with AWS, that means multiple data centers. So zonal will mean it will run in a single zone, in this case their zone called US Central 1A. Or we can click on regional and then it will distribute across multiple zones. I'm just going to stick with zonal to keep things simple for now. Going further down, we can change the machine type that we're working with if we want more powerful instances. The default is to use the N1 standard instance. Just to give you an idea, I'll use the navigation menu here, and it's the compute engine where we can spin up these virtual machine instances manually. and I'll open that link in a new tab. And this is the same idea as the Amazon EC2 service, where I can manually create virtual machine instances. And I'm just doing this little digression to show you that, again, much better than AWS this. We currently have an N1 standard machine selected here, and it will estimate the running costs of that instance. So about $25 per month for one of these N1 standard instances. If you wanted a high memory instance, it would be a high mem instance, and that's $60 per month. A high CPU instance, $36 per month. If we want a high CPU instance with 8 virtual CPUs, then we're looking at about $145 a month. Anyway, we don't need this screen because we're not going to create instances manually. Here on the Kubernetes engine, the engine is going to automatically create 3 of those N1 standard instances. So this cluster is going to cost around $75 per month to run. Remember, if you're new to the platform, then you will be on your free credits. I don't think we need to change any of the other options. Click Create at the bottom. And it's now going to create the cluster. If this is anything like AWS, this is going to take quite a while to configure. So I'll take a break and come back a little later. I've just waited about 2 minutes so far, and I noticed that after pressing refresh, it has filled in the table with some information. It has filled in the table with the cluster size, the total cores, and it has given me a connect button. However, the disk is spinning, and actually, just while I've been talking, it's now turned into a tick, which is telling me the cluster is running. So that was only about 2 minutes, but I did notice when I rehearsed this earlier, when I started connecting to this cluster, it did start timing out and falling over, and it did appear that the cluster wasn't actually running. So be aware of that. Let's see what happens if we click on Connect. Now, another really nice feature, I think, of Google Cloud Platform is we have a Cloud Shell, which is really useful because it gives us a terminal on a sort of throwaway instance that we don't have to bother starting manually. Now, back on the original course when working in AWS, I created a new instance which I called the Bootstrap, and it was from there that I ran all of the Kubernetes commands. Well, I don't need to do that on Google because I can just click on Run in Cloud Shell, and we get the equivalent of a terminal right here on the web page. And it really is as simple as that. Now, apparently we need to run this command gcloud container clusters get credentials, etc., but it's automatically pasted that onto the command line, which is so good. Now, it was at this point, and I just need to hit return there to run the command. And on my rehearsal, I was seeing errors here. And I just went away and came back. So I'm surprised that it does seem to have worked this time. Kubeconfig entry generated for Fleetman cluster. So if you have any problems at this stage, you might just want to go away, have a break, come back in 5-10 minutes or something like that. You should eventually be able to run this command and get no errors. And what we have here now is a terminal from which we can manage the Kubernetes cluster. If you're on this video, I'm assuming by now you're completely familiar with how to work with Kubernetes. kubectl get all should show you all of the resources, pods, services, etc. that you've deployed to this cluster. And the command was very slow. I did a video edit there, but eventually it has returned with the one default Kubernetes service. So it almost feels too simple. It's very elegant. We can also, rather than using the command line here, we can also use the panels here. We can click workloads here to see a list of all of our pods. Now it is inviting us to deploy our first workload. If you click on the deploy link, I was expecting here that maybe we could upload a YAML file, which would be quite nice, but it seems to be giving me a wizard, which is effectively building a YAML file through the user interface. So we can set a container image here and environment variables, and eventually that will generate a YAML file, which looks quite nice. I can't see a way of just uploading a YAML file. I'm sure we can. I'm sure it's not difficult, but I just haven't found it yet. If you do know how to do that, then just send in a comment. And it's the same story for service and storage and so on. So my plan is I'm going to keep things simple. I'm just going to copy my text files to here on the terminal and then deploy them. Just as on the course, I think I'm just going to do that by copying and pasting into a text editor. Now, of course, you wouldn't do that in real life. In real life, your YAML files would be in a repository somewhere. We'd be doing something like a Git clone at this stage. Well, I'm not even sure what distribution we're running on here. I'm sure Git, oh yeah, well, Git has been installed, so that's even better. But if it hadn't been, you would have used the package manager. As I say, I don't know what distribution we're on. I've got a feeling it's not Yum. It's probably apt-get then, and it is. I could have used apt-get there to install Git if it hadn't been there. Now, I just saw a warning flashing past warning me that, yeah, anything we install with apt-get, because it's on Cloud Shell, it's an ephemeral instance, meaning that when we log out of here, this instance is going to be destroyed, which is absolutely fine. Anyway, as I say, to keep things simple, I'm just going to use an editor to create my workloads.yaml file. I'm going to use VI, but Nano is available as well. So I'm going to create the workloads.yaml file, and I'm going to copy the entire contents of the file from the course. As I say, there is a link to my GitHub repository, which has all of these YAML files available if you need them. And paste into there. I don't think I'll tease you too much. There's going to be nothing in here that needs to change just because we're running on Google Cloud. So that's one file. We also have a services.yaml file. We will need to make some minor changes to this one, but we'll think about that when we get there. So I'll paste into that file and exit. And we also have that Mongo stack.yaml file, just for the Mongo database. That took up a few hours of the training course. That's all good. And the final file, I'm copying here the storage-aws.yaml file, which was also supplied as part of that course. Now, this is the one file that we'll need to change because we have some Amazon-specific information in there. So I'm going to call this file storage-google.yaml. Now again, I won't go into detail about the differences between storage classes and persistent volume claims. We had about an hour and a half on the training course talking about that. And it was definitely the part of the course that I found the hardest to record because it does look really complicated in Kubernetes that you have these persistent volumes, persistent volume claims, and storage classes and storage class types. And it all gets a little bit overwhelming, but the point I tried to make on the course was the idea was we can isolate the platform-specific information. The actual how do we want this to be implemented on our specific platform is all stored in one place. And I can prove that now. We can't use AWS's EBS service, but we can use the Google equivalent. And all I've done off camera is I've looked in the Kubernetes reference manual for storage class, and I've had a look at the variety of different provisioners that are available. And I discover that as well as AWS-EBS, if I delete that, there is also available GCE-PD, which stands for Google Container Engine, I think, dash persistent drive, I think. So it's just the Google equivalent of an Amazon EBS volume. And for the type, again, do look this up for yourself, but a PD-standard appears to do the trick. This is a standard persistent drive. Again, at the risk of repeating myself, the great thing about this is that that is the only place I need to make that change. Everywhere else in my YAML, I'm just referring to this persistent volume claim, which just happens to be pointing to this persistent disk definition. That is kind of the riskiest change that we need to make in this exercise. So I think I'm going to do a kubectl apply on just that storage google.yaml because I really do want to see that that works. Okay, well, it says it has created a persistent volume claim and a storage class. And we can verify that in the user interface. In fact, if we click on the storage link here, and this is looking promising, I have Mongo PVC under persistence volume claim. It does say it's pending, so I'm guessing it's still provisioning that. If we click on storage classes, then here's our new storage class, Cloud SSD. It looks like I could have used, in fact, the predefined standard rather than creating my own, which is fine. I'll just click refresh here. Yeah, I think the user interface, you do need to manually refresh that. It did look like it was creating for longer than I expected. But anyway, it is now saying that that PVC is bound. So it looks like we now have a hard drive created on the Google Cloud. Now the rest of the stack, I reckon we can just apply it. So kubectl apply -f and dot. We'll work on all of the YAML files. So we have a variety of deployments and services, and we can now check them on the workloads link. I'm immediately worried here. I didn't see this in rehearsals, but I'm guessing all that's happening here is these pods are still being created. So therefore the deployment that's managing those pods is showing in a kind of error status. I'm hoping if I refresh, it looks like things are coming together. The MongoDB looks like it might still be creating. And yeah, it was all just starting up. And just as previously, I could have used the kubectl describe to find out the status of the underlying pods. Now I'm seeing deployments here. I can't see the pods. So I bet if I click through to the MongoDB, for example, yeah, I've got full details, deep details, in fact, of what's going on here. Here's the underlying pod. And I bet if I click through to that, this really is fantastic. We can drill into the logs and then container logs. And yes, I can see the logs for that pod. So of course I could do all of that through the command line, but if you prefer the user interface, then that looks really neat. So it looks like our workload is set up, but what about our services? Well, the services.yaml file that I picked up was the same services.yaml file that we built on the early part of the course when we were running locally on Minikube. And for that reason, the Fleetman web app service is currently defined as a node port. If I click into that service, then I think what we've done here is we've defined port 30,080 to map to the container port of 80. Now we do exactly the same as this on AWS, but we can't access this port 30,080 because at present there's no public IP address for the cluster. So for that reason, the easiest thing to do, there are other ways of doing this, but the easiest and the most kind of production standard way of doing things is to change this service into a load balancer service type. I guess I can do that through this user interface. I'm not entirely sure, but I'm going to do that just by directly editing the services YAML file. And I'm just going to find in the YAML file, I think it's right at the top, here's the definition of the Fleetman web app service. And we set the type to be node port. If you come straight to this video and you haven't done the section on Amazon, then you won't know that I can change that type to be load balancer. And that tells Kubernetes to use the cloud platform's load balancer to access this service. Now you can only do that if you're running on a cloud provider. You can't do that when you're running in Minikube, for example. And you will need to remove the line node port :30,080 because that's only relevant when you're using a node port. That's the only change we need to make. If we save that and, well, we'll just recall the kubectl apply command, most of that will be unchanged apart from the web app, which has been reconfigured. And if I do a refresh now on this service list, we'll see a big and exciting difference. Under Fleetman web app now, it now says it's a load balancer and it is busy creating, well, it's effectively creating a load balancer now that it's putting in front of this service. I don't know how long that takes on Google. So that was about a minute, I would say, which is actually a lot quicker than it would have taken on AWS. Now, the big difference is under the endpoints list, this IP address is now a public IP address. The other IPs here, the ones beginning with 10, are all private IP addresses and would not be reachable from outside of the cluster. But with the load balancer, and just in case you are familiar with AWS, on AWS you do not get an IP address for the load balancer, you actually get a DNS name. The IP address for an AWS load balancer can change over time. It looks like, and remember I'm not an expert, it looks like on Google we get a static fixed IP address connected to that load balancer effectively permanently. And this is a dramatic moment on this video because all I have to do is click this link. If you're following along, I hope that's working for you as well. We are now seeing the live application running on this cluster. And just as we do on the training course, of course, we could now set up a proper domain name against that IP address. And I think if I select any of the vehicles, we should be able to see the history of the vehicles, just as we did on the training course. And just to check that that persistent disk is working, what should I do? I'm going to kill a pod. I'm going to kill the pod that is managing the Mongo database. I could do that on the command line. I wonder if I can do that by clicking on the serving pods. There may well be a delete pod option on here, and there is. Okay, we'll do that then. Okay, so now it's automatically put me back to the workloads list, so we can now see the MongoDB deployment is now in trouble because it doesn't have the minimum availability. Back to the app, because the database is not available, the vehicles will have stopped moving. Last reports were for the city truck at 12:42 and 16 seconds, which was quite a while ago now. And actually, just as I pulled the clock up, I have had a new report in at 50 seconds. And there's another report. So it looks like the system has recovered already. Let's refresh the workloads. And yep, that's now showing okay. And the thing we want to do, I did this quite a lot on the course. If I switch to another vehicle and then switch back to the original vehicle, we should still see, yeah, great, the full history of that vehicle is still in place. And that's because it was all stored on a persistent disk outside of the cluster. If that doesn't mean anything to you, then you probably haven't done my Kubernetes training course. There's a link in the description if you're interested. I think this is as far as I'm going to go with this demonstration. It really was just a demonstration, and I promise you, most of what I've shown you I didn't know this time yesterday. It really was surprisingly simple to get up and running, which is partly thanks, I think, to the Google Cloud Platform looks very slick and efficient, but also it's due to Kubernetes really allowing us to capture the definition of a full architecture without us having to do any manual work on our cloud provider's platform. Well, of course, we had to start up the cluster, but once that was running, then everything from then on was driven by those YAML files. We had to make a minor change to the YAML file. So to clean up, I'll go back to the billing page. That is going to cost me some credits, of course. As I say, as far as I know, when those credits expire, you will not have your credit card charged until you explicitly opt into credit card charging. However, having said that, just as on the course, I don't want to take that risk. You definitely want to go to the Kubernetes engine, find your cluster, and delete the cluster. Otherwise, at the very least, you're going to use up all of your free credits. You probably want to do some other work on Google Cloud Platform. I'm certainly impressed with Google Cloud Platform, and maybe in the future I'll get a chance to use it professionally. But until that time, I hope this has proved a useful demonstration of the power of Kubernetes to allow you to migrate even complicated applications from one platform to another. So thanks for watching. I've been Richard Chesterwood. If you found this useful, do like and subscribe. I will be providing quite a lot of free and useful information on my YouTube channel over time. I think I've said you will find the full Kubernetes course on the link in the description below. All the best. I'll see you soon.